Hello everyone and welcome to episode 3 of my series on computers, on Python programming, and on data science. In this video we're going to extend the kind of hardware to digital representation we did last time into how programs actually run on a system in this video. And this should be the last video we need before we can actually jump into programming. So here I've listed kind of what we saw last time, which is assembly language, right? So this is a set of instructions that follow the instruction set that an electrical engineer has made for their processor. And if you notice, in the first line here, we have a few things. We have a 0, we have this EB63, which will look confusing, we have the JMP, and we have the 0x65. So compared to last video, you will see JMP, right? So JMP is a command just like the MOV we did in the last video. Actually, MOV appears down here. You can see right here, MOV appears. But that's not the first instruction given. Oh, by the way, this is a Unix boot record. So this is like the first thing that's going to appear when you press power on your machine. It's going to execute these commands. And that's one of the things I didn't really bring up in the last video either is a computer will run one command at a time. Remember I said for that one example, we shoved that whole 64 bits into the processor at one time and one calculation happens. So the way a computer works is you have to shove that 64 in, send the next 64 in, send the next 64 in, send the next 64 in, and that's all one command happening at a time. And what a computer does is it'll just take this list of commands and run down, does the first one, does the next one, does the next one, does the next one, until it completes. And usually at the end there's either a whole bunch of no ops, or NOP is here, which is literally just the computer just sitting there doing nothing, waiting, no operation, or it will loop back and do it from the beginning again. So the first instruction here has the 0 here listed, and that 0 is the first spot in memory. And so that's one thing to note too, is in programming usually everything's 0 based. So that means that the first thing of an instruction set or a memory of or anything starts with 0, not 1. So in normal counting, you're like, well, what's the first number? You might say 1. Well, in programming, what's the first number? 0. Okay, so 0, this is showing that this is the first spot in memory. The EB63 is the hexadecimal representation of this command JMP, right? So we don't really need to go in depth with hexadecimal because it's not necessary to understand what's going on a computer, but it's just another representation. You know, we had assembly, we had binary, and we had English, and we had Python version that we talked about in the last video. There's also hexadecimal. But so you don't necessarily need that, so you can just kind of ignore that. Here we have the command JMP, and what JMP does is it jumps from one spot in the list of instructions to another spot in the list of instructions. So the next part is this 0x65. And that is similar to the HD1 that I had in the last video. This is the address that you're going to jump to. So the first thing this computer is going to do when it loads up is it's going to jump to 0x65, that's an address in memory, and start running commands from there. So the x65 isn't listed here, it only goes down to 44. But what it would do is skip all these instructions and go to whatever line number and start running executions from there. And so why is this important? This kind of is an explanation of how a computer starts running programs, right? So if the first thing it says is jump to this program and run this program, and then it finishes, that is not an operating system, right? That's just running one program. And an example of something that would run just a single program is something like an Arduino board, which you can buy for, $18 off looks like Amazon has it for $18. Another thing is like in a factory, you might have just a single board that performs one function, which is reading from a sensor and outputting that sensor data to a text file or something like that. So in that case, you're only running one program, which reads the sensor, writes it out to an output file. You might have, let's think of another example. You might, in a car, right? A car might have a single thing that reads the temperature of the car, right? So its whole job is read temperature, output it to your digital display in your car, and that's the only thing it's running for its entire lifespan. In that case, you have no operating system, right? You're just running a single program which runs from the first instruction of that program to the end of the program and stops, or just loops forever. Now that's not super useful for users like us because we want to run Google Chrome, we want to run Spotify, we want to run an app store, we want to run another app, we want to run a whole bunch of different stuff on our computer at the same time. And in that instance, you need an operating system, because what an operating system is going to do is, instead of reading the first instruction of the first program, then the second instruction of the first program, then the third instruction of the first program, it can instead run the first instruction of the first program, run let me restart. So it can run the first instruction of the first program, then run the first instruction of the second program, then run the first instruction of the third program, then go back and do the second instruction of the first program. So you can see how you can interlay programs together and have them running. And the reason that an operating system has to do that is it has to decide, okay, well, maybe I want to run 2 programs from the first, or 2 instructions from the first program, and then I want to run 5 instructions from the second program. It kind of decides how many instructions from whatever program is going to run before the next program runs. That's like scheduling in an operating system. So let's see what else an operating system does. So it says here, an operating system has 3 main functions. 1, manage the computer's resources. Let's talk about that for a second. In an Arduino that's just running one program, that one program is responsible for deleting memory when it's no longer in use. It's responsible for, if it's connected to a USB drive, for example, it's responsible for shutting off connection to that USB drive when it's done writing to it. It's responsible for, making sure that the display is already showing, and any peripheral or anything else that's plugged into the computer, that one program is responsible for figuring all that stuff out, which is hard to do, right? Because if I plug anything else into it that it hasn't recognized before, it won't be able to just decipher it immediately and work just the way it was before. An operating system, instead, you install what are called drivers and so like you may have seen when you install Windows or Linux or Mac, it says you need to update your drivers. It's because someone has created something like maybe a new version of the mouse that you're using, and your Windows system doesn't have the new code for that mouse. So you're basically installing the instructions that will communicate with that mouse, and the operating system will take care of that for you. It'll also automatically garbage collect your memory when you're done running a program. So let's say I'm running Google Chrome. As soon as I close out of Google Chrome, in a normal program like Arduino, all of the memory that's been used by Google Chrome will still be there and still be allocated for Google Chrome, even though Google Chrome's not working anymore. What Windows or Mac or Linux will do is they'll delete all of that memory that Google Chrome was using so that a new program can use that. So that's what it means by managing the computer's resources. The second thing it's going to talk about is establish a user interface, right? So usually when you use an Arduino that I was showing earlier, or a sensor board that I talked about, that's maybe in a factory, you don't have a display where users can read what the system is doing, right? It's just running, and you don't see anything, right? Maybe it's writing to a text file which you can later download from a hard drive or something like that, but you're not actually seeing it run. You're not seeing it actually happen. You don't actually know if it's running, maybe unless it has an LED light or something on it that's telling you that it's running. Whereas with a Windows system or a Mac system or a Linux system, you can actually see the display. Like you're viewing it right now, whatever operating system you're using that's watching this video, you have some screen that your operating system's communicating with to send it the various data to view. And like it also decides like if my Google Chrome is showing up in the front of my display right now, or if it's minimized, and all that kind of stuff. So the last thing, it says execute and provide services for application software. So that's the thing is, normally in an Arduino system, like I said, you only have one program that's running. You can't run multiple different programs at a time. With an operating system, you can have Google Chrome running, and you can have Spotify running, and all these different things at the same time. And the operating system decides which program is going to take priority, whereas which program gets to run its instructions first, and when do I need to interrupt with another program and have it come in and do its things. So that's what Windows does, what Mac does, and what Linux does. So there's differences between each of them, right? So maybe I think what's clear for Windows is that it's really user friendly, right? So it does a really good job at establishing a user interface, right? It's really easy for you to go and click on Google Chrome and it'll open, and you'll be able to type in really easily. It's pretty easy to just go to a website, download what you need, and it'll run, and then it'll start popping up in your window, and everything's really nice and user friendly. Whereas Linux is really nice for programmers because it's really easy for me to download a compiler or something that I need to actually run a program. And so they each have their advantages and disadvantages. I think Linux is also better at getting rid of memory that's no longer in use, and and Mac is just, you know, it's also clean and artsy. So maybe you prefer. I think it's similar to Windows in that regard. But so depending on which operating system is running, that's one more thing that you have to add on when you're downloading a compiler. Is your compiler has to match your specific operating system and also has to match the instruction set that we talked about in the last video. So is it x64? Is it x86? And what operating system are you running? And when you have all three of those things, you can determine a compiler, and from the compiler you have something that you can actually run programs with. I can make my own program. It can go into the operating system, and the operating system will allow it to run some instructions, and it'll go to the instruction set and actually, you know, do the command so that the hardware can run it and you actually have your calculation occur. So now that we have all of the requirements for downloading a compiler, what we're going to do is look at the Python programming language, right? So the reason that we're choosing Python for this description is the most data science tools so far are in Python, right? So you have neural networks, which is TensorFlow and PyTorch, and all of these new frameworks that have come out in the last couple of years. They're all written specifically for Python. There's been attempts to do it in other languages, you know, port it to other languages and stuff like that, but it's just the growth at which data science is happening is mostly happening in Python. So that's why we're going to learn Python. Also, like I said, the Yandex tutorial that I was invited to is also in Python, so that's what we're going to use. So if you're interested in specifics about what makes Python different from other languages, you can kind of read this Wikipedia page on it. I'm not going to go through it right now, but as you can see, it's been around since the 80s. And it was when it was conceived, and then in 91 it was first released, and since then it's been going. So that's what, like 30, 40 years it's been around. So it's a pretty well developed language, and people continue to add on to it just like they're doing with data science. So what we're going to need to do to actually run Python is we're actually go to the website. Let's see if we can get the link from here. So python.org. And then we're going to go to the downloads page. And we can see that the latest version of Python is 3.81. Even though that's the latest version, and sometimes you're like, well, I always have to have the latest version because that'll be the most updated and I won't have to do updates or anything like that. But that's actually not the case for data science. For data science, we actually want to be like a revision or so behind, because those frameworks that are actually doing all that cool data science stuff were built, you know, a while ago, right? They're not able to stay current with the current Python language right now. Like, it might be a few months before they catch up to 3.81. So actually what we want to do is probably go back to 3.7 where everything is compatible with it, and download that. So I'll go to this 3.76 and I'll hit download, and then we'll scroll down, and we'll see here they have specific instructions for Windows and specific instructions for Mac OS, and there should be one for Linux as well. Let's see. Well, so in Linux, you might just do an apt-get install, and it will install it that way. But for Windows or Mac, which is what I'm using right now, you'll notice that it has the operating system listed and the 64-bit versus 32-bit thing I talked about, and it should have an installer that you can use to install your program. So I will click on the 64-32-bit installer, and you'll see it's downloading down here. After that's installed, we can actually open it up. So if you're in Windows, you're going to go to your Start menu, and you're going to type in CMD, and it'll be the black window that pops up, cmd.exe. You click Enter on that, and it'll open a terminal window. In Linux, you can search for terminal, and it'll open that. In Mac, I'm here. I hit let's see. If I go to my Finder, I click File, and then I Find, and then I type in Terminal, and then I scroll down to the T's. Let's see. T-E-R. Here we go. This is terminal, and that will open up the terminal for your Mac computer. And then for all three commands, what you can do to check that your Python's installed is you just type Python. And mine says 2.7. That's incorrect. You should be on 3.6 that you've done. There's kind of a confusion because Python 2 is so different than Python 3. They now have sometimes install both on a single system. So if you're getting just Python 2 and you actually want Python 3, you can do Python 3 as the command instead of just Python and hit enter, and now you should see your Python 3.7 on there. So to make sure that it's working, if you see this little, the little carrots, 3 carrots, that means that you're in the Python world now, right? You can do Python commands and everything. So we can, for example, like we did in the second video, we had that command x equals 2. If we type that and hit enter, that works. That's a valid command in Python. Otherwise, you'll receive an error if it's not a valid Python. And then to get out of Python, we just type exit and then do 2 parentheses, and then it gets us out of the Python environment. Okay, so now you're able to run Python in your operating system of choice. And one last thing before we quit is we're going to install Jupyter Notebook, because that's the standard for doing data science in, because like Windows can save a file, when you're working on a Word document, in Jupyter Notebook you can save code as you go along. And so the way you install that is you type in your Python 3 and then do -m pip. So pip is like an installer for you, the Python that installs Python packages. So what I'm doing here is Python 3, that's just designating that I'm running a Python script. -m is a module, so there's an already pre-installed module for Python that's called pip, and that's the installer. I'm going to do pip install, then I'm going to type Jupyter, Jupyter, which is a framework or a notebook that can be used to save Python as you go along. So I hit enter, and you should see it install for your system. And to actually see it working, you can type in Jupyter Notebook, hit enter, and it should pop up in your web browser, this fancy window. And this will be like a directory of your computer. So maybe I want to save all of my Python stuff in my documents folder. I can make a new folder, and let's see if I can rename it. Let's see. Oh, here we go. So you put a check mark next to it by clicking on the left-hand side. You hit rename, and then I'll type it as Python tutorials. Okay, I'll click that, and now I'm in the Python tutorials directory. I'll click new, Python 3 notebook. It'll open a new tab. Then I can call this operating systems lesson. And then I can go up here and do my x equals 2 command. And the way you run it from a Python notebook is you do shift and then return or enter, and that'll run the command, and then that's done. And so you can go up to cell here and do run all, and that'll run all the cells. Or if you want to run the specific cell, you can do run cells, and that'll run it as well. And that's the end of this tutorial. That's all you need for us to begin our journey in Python. So I'll see you in the next video. Thank you so much.